So you should record anything that I talk about that is not in the answer that I have. You should document that on your paper. If you have what I have, it doesn't have to be exact word for what I say. So if you have what I have, then you can just go ahead and write correct, correct next to the question so that I know that you've watched the whole video. Okay. All right, so a circuit containing 3 identical bulbs in series will have equal flow rates through all bulbs when the steady state is reached. Will it have equal flow rates through each bulb in the transient stage at the instant connection is made? And the answer to this is no. Initially, there is no pressure difference across the middle bulb. I've got yellow to yellow. And so when we were looking at it, it appears to light at the same time. But when we added a capacitor to this circuit, so when we added the capacitor, what we found was that there was a delay in this bulb lighting up, which means that the pressure difference here has to build up during the transient process as charge flows through the other 2 bulbs. And so the experiment where we did this, added a capacitor, and we saw that it took more time. I actually think you might have had 4 bulbs. Took more time to light the middle bulbs, shows that pressure has to build up in these 2 branches in order for those to light. Now, it happens very quickly without the capacitor, but there is some time. Okay, question number 2. A single long bulb is connected to a fresh battery. When a second long bulb is added parallel to the first bulb, there is okay, I did multiple batteries. Sorry about that. I drew my little thing to the side. So this is what we have initially. And when we add a second bulb, this is like adding our straws side by side so we can have more flow. Through the circuit. The electric difference across the battery terminals, that's going to be little to no change. The battery pressure difference is determined by the chemicals inside the battery, and so doesn't matter what's happening in the circuit outside it. The battery terminals are going to essentially be 1.5 volts no matter what. Electric pressure difference across the first bulb. Well, if we think about coloring this, this is all yellow and this is all blue. And when I add the second bulb, this is still blue and this is still red. So as before, we're going to have little to no change. The flow rate of charge through the battery, this is actually going to increase, and it's because I've added another branch so I can have more charge flow, and that's going to increase the flow rate of charge through the battery. And then the flow rate of charge through the first bulb, again, we can tell just from our color coding, we're going to have little to no change. Okay, number 3. And you may ask, do I need to draw these circuits? You don't have to, but I think it might help you picture it. Up to you. All right, number 3, is the net resistance or total resistance of a series combination more than the resistance of any single bulb in the combination? Why or why not? And you know just from doing the experiment where you started with 1 bulb and then added 2 and then added 3, these are in series, that these increasingly get dimmer. And the reason why is it's like I'm splitting the pressure. So initially, to go from red to blue, all of the red to blue difference went through the first bulb. But then I'm just going to draw blue on all of these. In order to go red to blue, when I had 2 bulbs, I had to do an increment. Okay, so I had to go through yellow. And then in order to go through those bulbs, I'm going to do yellow-green. And so it's like I had to split the change or the pressure difference through the whole circuit. And each time I like decreased the amount of steps from high potential to low potential, my bulbs get dimmer and dimmer. Okay, is the net resistance of a parallel combination more than the resistance of any single resistor in combination? And the answer to this is no. I guess I should have put for the number 3, this was yes. Number 4 is no. And the basic idea is that I have more paths, and so I can have more flow. And the reason, again, this is like when I put the straws side by side, I just have more paths, and so I can have more flow. And so that means more flow means less resistance. So less resistance leads to more flow, or more flow because of less resistance. Okay, number 5, how does the flow rate of charge in a parallel circuit divide? If all branches of the circuit have the same resistance, then the flow rate is equal. In all branches. And if different branches have different resistance values, then the low resistance has more flow. So the idea is that electrical energy takes the path of least resistance. It will still split. It will just be an unequal split with the greatest fraction going through the branches that has the least resistance. All right, does choice A or choice B provide the best representation of the transient process that occurs after the circuit is closed? So I think that it might help to kind of color code some of this. So we know that the instant of first closure and also the steady state, that's going to be red. And we know that this is going to be blue. And we know that this is going to be neutral. That's how it starts, and it hasn't had time to change yet. So if we look at choice A, that shows energy kind of stacking into the middle wire, whereas choice B shows energy leaving the middle wire. And I think that energy has to stack into the middle wire so that the flow rate becomes high enough for the second bulb to light. And so I think that in the steady state, therefore, this is going to be orange. So that we can, and with the idea that this is the brighter bulb, and so I need to have a greater difference in pressure here than here. Okay, so if this middle bulb were yellow, then these would be equal brightness, or this middle wire were yellow, then these would be equal brightness. And so I have to make this one have a higher pressure, and so this shows higher pressure going into the middle. So yellow goes to orange. Hopefully that made sense. All right, a simple circuit contains a battery and a single light bulb. What effect does adding a wire in parallel with the light bulb have on? Okay, so we're adding a bulb, we're adding a branch in parallel. And so this branch has effectively no resistance. And so this means it's going to take all the flow. So the electric pressure difference across the bulb, this is going to go to 0. And this is called shorting out the battery. The flow rate of charge through the bulb, this is going to go to 0. And then the pressure difference across the battery terminals, this is going to decrease because I have a lot more flow. So